Hello, this is topic 5.8, the chemistry, mechanism, and rate law. The objective of today is to be able to identify the rate law for a reaction from a mechanism if the first step is the rate limiting. So this is going to lead us into what happens if our rate limiting step is not the first one. So this is a intro into this or easing up into that. The speed of a reaction is limited by the speed of the slowest step in the reaction mechanism. The slowest step is called a rate limiting step or rate determining step, so you may hear me use either one. And this is because it determines the rate of the overall reaction. In the case where the first step is rate limiting or where all reactions are irreversible, the rate law of the overall reaction is determined by the rate law of the slowest step. So it will tell you, where you will see, most likely, this is a slow step, this is the fast one, etc., or a fast one. So if the first one is slow, you can do what we're going to do now. If that's not the case, then you need to do other things as well. But we will get there when we get there. Let's look at our first example. Using the reaction mechanism shown, determine the rate law for this catalyzed decomposition of hydrogen peroxide shown above. So we have our overall mechanism on top. We have a slow and fast step. Our first step is a slow one, so that's the rate determining one. So we have to determine the rate law. So this is not just math, this is actually some words that are involved with this, so let's be prepared for that. The rate law for the slow step, or step 1, is inferred by the collisions of their reactants and is found to be rate equals K times H2O2 times iodide ion. Since the slow step is also the rate determining step, it can be concluded the rate of the overall reaction is rate equals K times H2O2 times I. Ooh, that was a lot of writing and a lot of talking. Okay. The rate law for the decomposition of nitrous oxide N2O is found to be rate equals K times N2O. If this process does occur in 2 steps as shown below, identify the slow or rate limiting step, justify your answer. So again, we can say we're talking about the slow step and all that blah blah, but we have to be able to say it, articulate it the correct way. So the slow step is the first elementary step. First elementary reaction, because the rate law rate equals K N2O matches the rate observed. When I'm talking about the rate, I'm talking about this. So basically, all of it's saying is, how do you know? You know because a slow step. So basically, because the rate law that is determined matches step 1, therefore that is the slow step. It's kind of a weird way of saying it, but yeah. The rate law for the reaction between NO2 and CO is experimentally determined to be rate equals K times NO2 squared. Two mechanisms are provided below. Based on the information above, does the reaction between NO2 and CO occur in the 1 step or 2 steps? Justify your answer. So looking at this, knowing our rate law is up here, it cannot be mechanism 1. It's mechanism 2. Because if we look at our reactants in mechanism 1, it does not match the rate law. So which is pretty much what the question is asking. So based on this information, blah, 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 is it 1 step or 2 steps? Justify your answer. So now we need to say words to justify it. The reaction occurs in a 2-step mechanism because the rate law for the slow step matches the observed rate law. All right, gentlemen, if you have any questions, please let me know. Hit the like and subscribe, blah, blah, blah. Thanks, bye.